Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, yes, the material for chapter number 2 are included in quiz 2 for chapter 2. So half of the material of today, the material that we will mention today under chapter number 2 are all included in the quiz inshallah. تمام؟ يبقى الماتيريال اللي هنقولها النهارده في نص الليكتشر الاولانيه داخله كلها في الكويز بتاع يوم الثلاثاء ان شاء الله. We refer to chapter 3, chapter 2 here. Okay, once we start the addressing modes in chapter 3, this is next chapter. This is chapter 3. Okay, first of all, welcome everybody to the microprocessor class, and we are in chapter number 2, microprocessor architecture. We have a few things to close before we go to the next chapter. As I just mentioned, our quiz will be next Tuesday. Similar to the previous quiz, maybe have a little bit of calculations, as we know how to calculate the address, physical address, the logical address, the offset, the segment, in addition to true and false and some maybe multiple choice. It will not be long, maybe 10 to 15 minutes, similar to quiz number 1. So today we are in lecture number 10, okay, for the microprocessor class. Today we will be covering the following items. The first thing to cover is the RISC and CISC. Second thing is the data types. Third thing is the status register, which is the last register that we want to learn before we go to the programming in chapter 3. First thing here, the first item today is the RISC. The microprocessor designers, the computer architecture, have been built based on, they classified into 2 categories. Okay, they classified into 2 categories. We mentioned before the 2 major ideologies or vendors to build the machines. We have what's called the RISC machines, and we have what's called the CISC machines. RISC stands for Reduced Instruction Set Computer. CISC stands for Complex Instruction Set Computers. Exactly. Type. From the name, you can recognize the difference. By the way, who built their computers using the RISC machines is the company called IBM. Okay? They build their processor and they call them the power machines or power architecture. The company اسمها IBM, the name of the architecture they call it power. Complex machines is being built by Intel and AMD, and they base their architecture on the x86 machines. تمام؟ طيب. Okay, good information so far. طيب. What is the RISC and what is the CISC? What is the difference? The first difference that we learned between the RISC and the CISC. أول فرق عملناه، أول فرق إحنا عرفناه already ما بين الباور ماشينز وما بين الريسك ماشينز وما بين السيسك ماشينز. مين شاطر يقول لي؟ لا اتعلمناها خلاص. لو ايه؟ هو مين ده اللي كومبلكس؟ مين ده اللي لو؟ ايوه محمد باشا. هنا they use little Indian order to sort the word of 2 bytes in the memory. The low byte will go to the low address, the high byte will go to the high address. In power machines is using what's called the big Indian order. Big Indian order is the opposite. The high byte of the word go to the low address and vice versa. Okay? Right. One more difference that we want to learn between the RISC and the CISC machines is coming actually from their name. This is called reduced and this is called complex. Okay? Reduced, when IBM built their power machines as RISC machines, they want to build the simplest processor ever. So they don't need a complex operations or complex architecture. So actually, they used the knowledge that we have in DLD, like means adder, subtractor, okay, maybe multiplier, okay, to build the processor. So they build the microprocessor with functional units, that has few capabilities, that has small capabilities. That's why they call it reduced instruction set. So when I have a few functional units, when I have a few functionalities, a few operations, this is directly will reflect on اللي بتقول عليه مها اللي هو ايه بقى؟ This will reflect on the instruction set. ما هي instruction set is following the functional units. If I have a complex function unit to do complex operation like what? Calculating power, calculating log, calculating sine, calculating tan, calculating the log, okay? Square root, the root of 3, okay? Power of 5. If I have functional unit, okay, multiplication is considered to me not complex. Multiplication not considered to be. Multiply and divide is not that complex. Okay? But even if I like you can claim that multiply is a complex operation. If you even say that the multiply is a complex operation, I want only to use addition and subtraction. Can't you still use the processor to do multiplication without a multiplier? You can or you can't. If the microprocessor is only doing an add and subtract operation, can you do multiply? Or that means I cannot use this microprocessor. طيب تمام؟ معلش كل إجاباتكم غلط. ليه؟ microprocessor by itself does not have an instruction for multiplication. But can't you use this general purpose machine to do multiplication? You can or you can't? You can. ازاy? Because the multiply mathematically is just a recursive operation of addition. يعني لو انا عايز اضرب 5 في 3 اتعلمنا زمان ازاي نضرب 5 في 3. جم قالوا لنا يا حبيبي عشان تضرب 5 في 3 يعني معنى كده انك بتكرر الخمسه 3 مرات. يعني ايه بكرر الخمسه 3 مرات؟ يعني بجمع 5 على 5 على 5. When I add the 5 3 times, I will get the result of 15, which is the multiplication between 5 and 3. مش كده ولا ايه؟ Okay, so actually I can dissect the multiply operation to a basic add operations. مش كده ولا ايه؟ Agree? Make sense? مش كده؟ تمام؟ So that means even if the RISC machines will not have a multiplier, okay, I still can multiply. ازاي ده؟ how can I use the microprocessor to multiply by a microprocessor that does not have a multiplier. هعمل ايه؟ هعمل ايه؟ The whole purpose of this هيستخدم الادر. طب هستخدم الادر ازاي؟ How can I use the adder to do the multiply؟ ايوه كده، ايوه يا عمر، هو ده اللي انا بدور عليه. Software. I will write a code, I will write a program that will actually do this operation for me. I will order this program to add the first number to the second number, and then the result will be added to the third number, and the final accumulative result is what I'm looking for. That means I can use the functional unit in hardware multiple times, okay, through a program to be written to achieve the multiply operation. Okay, I am moving things from the hardware to the software. I have basic elementary hardware, but since this is a programmable device, the microprocessor is a programmable device, I can write a program to achieve what I need from the basic operation. But at least I have to have the basic operation. The minimum that I can have is addition, subtraction. Through addition, subtraction, I can multiply, I can perform multiplication, division, or even the most complex things. So actually, this company, or the people who are buying the idea of the RISC, reduced instruction sets, they simplify the hardware and move the complexity to the software. Okay, they do a basic elementary hardware that can do the basic operations, and they move all the burden to the programmer. روح يا عم، عايز تعمل اي complex operation اكتب لها برنامج. ايوه جميل، حلو قوي، الناس مصحصحه معايا وبتفكر اهي. طيب هل ده بقى احسن ولا اسوء؟ ده سؤال. قبل ما نجاوب على السؤال ده، يبقى احنا هنا ايه؟ هنا يبقى I have a simple operation. Add, sub, okay, something like this. Okay, for the CISC I have complex operation. That means in addition to the add and the sum, maybe multiply, which may be exist in both, divide, I can have square roots, I can have a log, I can perform a power, okay, I can calculate sine, cosine, something like this. Okay, so those people are doing a complex operations, so they complicate the hardware. Okay, those people say no, we want to simplify the hardware and shift the complexity to the software. Those makes the life of the programmer easier. Okay, those give a nightmare to the programmer. تمام؟ طيب هنا very important question. Who of those is the winner? Who of those at the end of the day giving to the user a better machine or a faster machine? حلو قوي، better دي مش السيسك. مين قال كده؟ Not necessarily. ليه بقى؟ It depends. It depends on the application. اصبروا شوية، ما تسرعوش في الإجابة. Okay? Your answer is correct for the operations that is given here. Assume that in this machine I have a functional unit to calculate the log. If I wanted to calculate the log here on the RISC machine, definitely the log here will beat the log here, okay, in speed. ليه؟ لأن هنا I have to write a program for the log. Okay, this is the superficial look into things, because here you are writing software. But remember something, there is something very important that you have missed. From the beginning, those build their hardware as simple. Reduce the instruction set, simple hardware, simple operations. This allows them to optimize their design and make it faster than this. يعني الهاردوير هنا is slower than the hardware هنا. ليه؟ لأن ده complex وده simple. Okay? But here, in order to do a log operation, here I want to write a software, a program that is running يبقى slow, software running on يبقى fast hardware. Here I have from the beginning slow hardware. Here I don't need, okay, to write a software. It's only one instruction can calculate the log for me. But this log operation by itself is slow. They're slow because the hardware is complex. Because actually to build a hardware to do a complex operation, I need a lot of logic. Remember something, okay? We in DLD have built a multiplier بالعافية. We have seen how complex is building a multiplier, okay? So that means if I want to perform a complex operation, that means my hardware is getting much more complicated. More complicated hardware means more slower hardware. Okay, so the hardware here is definitely slower than the hardware here. But who is at the end of the day is the winner? We don't know. It's a race between those two ideologies. Okay, and you cannot judge with only one simple operation. In order to really, okay, judge who is faster, you have to go and bring a real application. Okay, go and bring your WinWord or your Doom game or whatever 3D Studio, and run the 3D Studio with all the code for the run the 3D Studio on a RISC machine and on a CISC machine. Okay, and then you can decide: is the simple operations but a lot of instructions and codes to perform them is faster, or a complex hardware and operations and few lines of code is faster? I don't know. There is no winner here. Okay, it depends. Amen? Agree? Make sense? Exactly, like the high-level language and the low-level language, okay? Writing your code in low-level language will definitely be better, because actually you have control over everything. You can optimize your code. You can squeeze the performance of the hardware. But when you go a high-level language, each statement in your high-level language will be automatically extracted through the compiler by many of code lines. Agree? Make sense? Yes, x86 is produced by Intel and AMD, and it is a CISC machine. Power is a RISC machine. Tamam? Agree? Make sense? Any question? عايز حاجة؟ خلصنا أول موضوع النهارده. تمام؟ في بقى حاجة تانية، سوري، في حاجة لا ما خلصناهوش. حاجة مهمة. تمام؟ In order for them, this is very important. كنت هنساها. Okay? يبقى هنا simple و complex. The instructions, one of the specifications to build a reduced instruction set, a RISC machine, is to have all the instructions equal in size. Okay, maybe one word for all instructions in the machine. El-complex have variable size instructions. So some of the instructions here may take 1 byte in the code segment, and some of them may take 5 bytes or 6 bytes. If the size of the instruction here is different than the size of the instruction here. There are 3 very confusing things that we will talk about in next chapter. The instruction size, the data size, with operation size. You have to discriminate between those 3 things because students mix them together. Here we are talking about the size of the instruction. الانستراكشنز موجودة فين? Where is your instruction in your program? In which segment the instructions? طبعا هو كله في الميموري. أنا بتكلم على segments. Okay, in the code segment. Okay, so instructions are occupying the size, their size in the code segment. Okay, they are populated in the code segment. وبرضه عايزك لازم تفرق ما بين الكود سيجمنت والسي اس. ايه الفرق بين الكود سيجمنت والسي اس؟ عشان برضه بيبقى فعلا لخبطه. هنتكلم. طب ماشي، خلينا نقولها ونخلص، مش كده؟ السي اس is the register that carries the starting address of the code segment, but the code segment is the code segment itself. تمام؟ يبقى CS is the name that we give to the register that has the starting point of the code segment. But the code segment is the code segment itself. It's the code, it's your code. When you write the code, it is in the code segment. And the code segment relies on the CS to identify its starting point. تمام؟ فالcode segment carries what? Carries the instructions. The instructions for the system machine are varying in their size. يعني تكتب instruction تطلع 1 بايت، تكتب اللي بعدها تطلع 1 بايت، تكتب اللي بعدها تطلع 5 بايت، اللي بعدها 2 بايت، اللي بعدها 1 بايت، وهكذا. They are variable, which adds to the complexity of the machine. Here they want to simplify things, so they fix the size of the instruction to be maybe 1 word or 2 words. It depends on the agreement and the architecture that they are using. Agree? Okay? Agree? Makes sense? تمام؟ عرفنا الفرق بين الريسك والسيسك. Any questions؟ أي سؤال؟ طيب. طيب. أي سؤال يا شباب؟ لا. الword size is fixed to be 2 bytes. The word size is fixed. The word size was changing while they are developing the machines anciently from the 1970s. Okay, but once they start, the agreement is to have the word size of 2 bytes since the 80s, and later on they are building the machines with a bigger size. Okay, but they keep the name word as of 2 bytes. يبقى الword size is not changing. The machine, okay, architecture is changing without changing the size of the word. Okay, so machine could have a double word or a quad word, as we will just mention. We will talk about the data types and the data size, which is our next subject. Remember that we are talking about the 8086 machine. Remember? In 8086 machine, the word size is 16 bits. Okay? And for the x86 in general, okay, they don't change this term. They fix the word size to be 16 bits. Our machines today are not 16 bits. The machines of today are 64 bits. So that means they are quad word machines. Okay? We don't want to confuse the programmer, so they fix the size of a one word to be 16 bits, shall we 2 bytes. In your code, while you are doing assembly, you can reserve. يبقى احنا عندنا دلوقتي بنتكلم عن الداتا تايبس. الداتا تايبس والداتا سايزز. Okay? Data sizes, we can go over it very quickly. I can reserve in the data segment the data with different sizes. Okay? We will go over that in chapter 3 in details. Okay? But I can reserve a slot of 1 byte. Okay? Or I can reserve 1 word, 2 bytes. Or I can reserve 2 words, we call them double word of 4 bytes, and I can reserve 4 word, or they call it a quad word of 8 bytes. Okay, these are the basic ones. There is also, in some instructions, they are dealing with a smaller than a byte, half of the byte, half byte. الهاف byte ده بيسموه level. How can I reserve the data in my data segments? Each of those has a way to define it. Okay? You want to reserve, and نتكلم عن reservation, على assigning the variables, defining the variables in your data segment. بنتكلم على data segment. Okay? Like the C language. مش انت C language بتعرفوا حاجه اسمها say integer, unsigned integer, وcharacter, وfloat, ودouble, مش كده؟ In C and C++, you know that. Okay? Here we don't have this. Here, in order to write the code, I'm defining a byte. So in order to define a byte, I will use the DD to define a byte. To define a word, I'm using DW. To define a double word, I'm using DD, define double. To define a quad, I'm using DQ. If those 2 letters will actually indicate the size of the data that I wanted to reserve in the data segment. Okay, we will see more example of this when we go to the coding in chapter 3. But this is the basic definition. Okay. طيب ده بيتكلم هنا على ايه؟ على الداتا سايز. يعني انا بتكلم على داتا ايه؟ الداتا سايز. يبقى هنا what I listed here on the board is actually defining what? Defining the data size. Sizes. Data sizes in bits or in bytes. Data size is different from the data types. 8 data types. 8 data types. DLD. الناس الشاطرة في DLD. الناس اللي بتفهم DLD. يعني ايه داتا تايب؟ خدنا حاجة اسمها داتا تايبس في DLD. خدنا حاجة اسمها داتا تايبس. ايه هي الداتا تايبس؟ What are the data types that you know? What are the data types that you know? لا دي numbering systems. الباينري والهكسا دي different numbering system, not different numbering types. ايوه ما بيرفكت يا مها. احنا خدنا ايه؟ خدنا لا ثواني بس يا تمارا، يا تمارا ما تلخبطش الدنيا في بعضها. الكاركتر والسترينج والانتجر والفلوت are actually mixing between the data size and the data types together. Okay, those in high level language. Those in high level language. Here we have to discriminate between the data size, which we define here. يبقى بالنسبة للداتا sizes we have 4 definitions: byte, word, double, quad. This is the data size. What is the data type? We will be dealing with 2 data types في الاسمبلي. خلاص؟ الاثنين دول احنا درسناهم كويس قوي، تمام؟ وتعاملنا ما قالتهم. خلاص؟ درسناهم كويس قوي وتعلمناهم كويس قوي واشتغلنا عليهم فين؟ في الدي ال دي شابتر 1 اللي هم مين بقى؟ يبقى الداتا تايبس that we will be dealing with are 2 main data types that we will be dealing with. اللي هم مين بقى؟ unsigned, signed, two's complement. لا وفي واحد كمان signed magnitude. If you don't know the difference between those 3 data types, go to DLD chapter 1 and review them well. Because without knowing those 3 data types, you will struggle significantly in this course. There is also one data type that we will deal with, which is actually called ASCII or string. ASCII. We also mentioned that in this is for characters. English characters. English for English characters. These are the data types that we will be dealing with. يعني ايه this is the data types؟ يعني remember something. احنا from day number 1 in DLD we are talking about binary. يعني ارقام وحايد وصفار. Okay? So I just want to bring this to your attention. What is this? This is 8-bit number. مش كده ولا ايه؟ صح؟ This is an 8-bit number. تمام كده؟ يبقى ده 1 byte. It is stored in the machine as a 1 byte. Stored in the machine's 1 and 0s شكلها عامل كده. طيب. Now I want to deal with the data. What is the meaning of those bits? طبعا هنا لو انا هحط ده هنا in byte صح؟ دي هنا بنحط البي دي عشان نindicate ان ده بايت. طب لو هحطه كهكسا ها؟ ده ايه ده؟ ده 1101. هحطه كهكسا هقسمه ل4 و4 مش كده ولا ايه؟ صح؟ 1101 اللي هو مين؟ محدش بينطق. بلاش. 0101 ها؟ محدش مذاكر؟ محدش فاكر؟ محدش معاه كالكوليتور طيب؟ 0101 يبقى ايه؟ يبقى ايه طيب؟ و0111 يبقى مين؟ يبقى ايه؟ ده بايه؟ بالهكسا. Agree? What this AE represents? What's this AE represent? Can you translate to me this AE? معرفش. Okay? I need humanly to understand what is AE. اقدر كده احط لك في وشك AE كده واقول لك ترجمها لي، قول لي دي ايه؟ ده مجرد رقم بالهكسا متخزن في المكنه. متخزن فين؟ ويمثل ايه؟ This is what we are looking for. Okay? If this
I think this is cutting.
Hello? Can you hear me? Can you see me? طيب لما انت خزنت
Doctor, there's no sound.
Hello? Can you hear me? بلاش فيديو ولا ايه؟ عشان تسمعوني؟ بس هتشوف السبورة ازاي؟ Can you hear me?
Doctor, we can't hear again.
Hello? 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 Can you hear me? Can you hear me?
Yes, doctor, we hear you.
Can you hear me now? After the video؟ ما هو الفيديو شكله ها سامعني كده؟
Yes, doctor, we hear you.
طيب تمام. Okay, so when you go and define a byte in your code, in your data segment, and you provide the value AE to this byte, is this indicates what kind of data that you are storing here? How many options that you have, at least from the knowledge of DLE? You have at least 4 different meanings. You may store this byte and you mean to store the value of the ASCII code for some character in English. Yes, I go to the ASCII code, the letter B or letter F or whatever, letter Q has okay, so it depends, the type of this data depends on whom? Depends on the assembler, depends on the microprocessor, depends on depends on the programmer. You are putting this data and you mean something about this data. Okay, so that's what we are discussing here. When you reserve the data in the assembly, You only define its size, but nothing will tell you what kind of data this means. Okay? Only the programmers know what kind of data you want to store there. Okay? And what we will be dealing with throughout this course is one out of those types. We may be dealing with ASCII characters to store some text in the memory, or we may store some sign magnitude numbers, okay, which is not the commonly used for our chapters till the chapter number 4, okay? We will not use it extensively. We will use it later on, okay, towards the floating point representation. But the two most representations that we will be dealing with are the unsigned numbers and the signed in 2's complement. Agree? Make sense? If you don't remember those, you have to go to DLD and review them. You have to go to DLD and review them. ماشي كده يا شباب؟ Agree? Make sense? تمام؟ يبقى unsigned numbers means this number in order. So if you tell me that I reserve this as an unsigned number, unsigned, now as a human being I can indicate its value. مش كده؟ اقدر احوله لفاليو، تمام؟ اعرف الفاليو، اعرف المينينج بتاع الرقم ده. لو قلت لي ان ده unsigned هعمل ايه؟ عارفين انتوا خلاص؟ يا اما استخدم الكالكوليتور يا اما اعمل ايه؟ حد لسه فاكر الرول؟ ها كنا بنعمل ايه؟ 0 1 2 3 4 5 6 7 2 to the power 1 plus 2 to the power 3 plus 2 to the power 5 plus 2 to the power 6 plus 2 to the power 7. I know what kind of value that you are storing here as unsigned. The exact same AE, okay? If I store it as a signed 2's complement, okay, does it have the same value? خلينا نعمل ايه؟ خلينا نعمل الاكسرسايز ده. Let's do this exercise. Let's do this exercise for that example here. ايه رايكم؟ عشان نوضح الفكره. مين معاه كالكوليتور ويقول لي الرقم ده يطلع كام unsigned؟ مين شاطر؟ AE بالهكسا يعني كام بالايه؟ بالديسيمال. ديسيمال بقى. ده ديسيمال نمبر. محدش شاطر؟ كالكوليتور احسبها لك. ايوه 234 decimal. يبقى if I'm storing this and I as a programmer mean to have it as an unsigned number, this means the number 234. Agree? Make sense? Right. What if I'm storing this and I mean by this number as signed 2's complement? Is this a positive or negative number? Negative. طب negative كام؟ If I do it like a DLD هاخد الرقم ده، اتعلمنا الطريقة بتاعته بنعمل ايه؟ Convert it using 2's complement 0 1 1 0 1 0 0 0 2 to the power 0 1 2 3 4 5 6 7. That means this is actually 2 plus 4 plus 16 اللي هو يديني كام؟ يبقى الرقم ده اللي انت مخزنه هو في ال AE actually is minus 22 in this. رقم negative minus 22. Okay? Right. If it is sign magnitude, نعمل ايه؟ This is a negative number and this is the magnitude of the number. مش كده ولا ايه؟ صح؟ 32 64 هنا عندي 8 وهنا عندي 2 يبقى دول 10 ودول 90 100 كام؟ minus 106. Perfect. Hell. طيب. What if I meant to store here AE as ASCII? Okay. I go to the ASCII table. Okay. We have what's called the ASCII table. تمام؟ ندور في الاسكي تيبل على ايه؟ على ايه هو الكاركتر اللي بيتكتب as an EA. حد جابه ولا ما جابه؟ حد جابه؟ مش موجود ها؟ مش موجود. خلاص يبقى ده ما ينفعش يبقى اسكي. تمام؟ It's out of range maybe. لا موجود اهو. It's a gamma symbol. It is a gamma symbol. مش يا شباب؟ حد فاهم حاجه؟ يبقى الاسمبلر ولا يفهم اي حاجه. انت بتستور سايزز وبتستور داتا تمام في الايه؟ في الداتا سيجمنت بتاعتك. مين يفهم معناها؟ انت اللي مخزنها وانت اللي عارف تقصد بيها ايه. اوكي؟ So you are using your assembly or the assembly code to writing codes for either unsigned numbers or signed to complement, maybe signed magnitude or ASCII. تمام؟ أي سؤال؟ Any question? Okay. You have to review the at least unsigned and signed for now. Signed magnitude, you have to review it to it because we will use it at the end of the semester. Any question? Any doubt? Right. Clear? The ASCII, go to Google and write ASCII table. Search on Google and write ASCII table. Go to Google and search for ASCII table. You will find a table that shows you each character, each English language character on your keyboard and how it is represented in the ASCII. Our machines, all of our machines are using the one standard ASCII table for the conversion of the English characters. Right. What's next? The last thing in this chapter is to talk about the last register, which is what's called the status register. Status register is a 16-bit register. 16-bit register. Okay? However, the programmer has access to 9 bits out of those 16 bits. Okay? This is the only register that you actually, each of its bits has a meaning uniquely, distinct, مش على بعضه كده. Okay? What is the status register? The status register is a register that actually indicates to you how healthy is your mathematical operations while you are writing the code. لا مش consecutive يا بنتي، ما انا حاططهم اهو، حاطط ارقامهم. اوكي، بيت نمبر 0 وبيت نمبر 2 وبيت نمبر 4 ونمبر 6 ونمبر 7 ونمبر 8 ونمبر 9 ونمبر 10 ونمبر 11. اوكي. Okay, the other ones are reserved, are not for you, you don't have access for them. Okay. تمام. طيب, what are those bits? Those bits are, the first one here is called the carry, they are called them flags. So this is the carry flag. Okay. The second one is called the parity flag. Bit number, you don't have to memorize their order. تمام. You have to know their acronym, their short name, and their usage. هو ده الأهم حاجة. أنا مش عايزك تحفظهم، مش هتحفظهم لي، لا، ولا تحفظ أماكنهم، يعني قصدي هتحفظهم بس مش هتعرف أماكنهم، مش مهم تعرف أماكنهم، المهم تعرف هم بيعملوا إيه، كل واحد. خلاص؟ ده الزيرو فلاج، ده الساين فلاج، اللي بعده التراب فلاج، اللي بعده الانتربت فلاج، دايركشن فلاج، واخر حاجه هي الاوفر فلو فلاج. اوكي اوكي تمام. طيب, we will only deal with those: an overflow, parity, zero, auxiliary, sign. Those three we will defer them right now. Direction we will not even go over it, but the trap and the interrupt we will discuss them towards the end of the semester. Last chapter 5 في السمستر هنتكلم على التراب والاي فلاج، مش في يعني في اخر شهر. تمام. Now we want to focus on those 6 flags. Those 6 flags are very important. Okay, we need to know the meaning of each of those. Okay, you are doing a mathematical operation, and now we want to go back to refresh our memory about the DLD. تمام كده؟ طيب, في DLD كنا بنعمل addition و subtraction و multiplication، كمان هنا بنعمل division. تمام كده؟ اوكي. If I am adding unsigned numbers, خلاص اتكلمنا عن unsigned numbers وعارفينهم خلاص. If I am adding 2 unsigned numbers, okay, we mentioned that there are special cases that may happen. Remember something, you are adding, for instance, assume you using this instruction, add AL, AH. What is this instruction? This instruction should add the register of 1 byte of AH to the register of 1 byte of the AL, and we put the result back into AL. Okay, we will discuss this in details, but I don't care about all of this. It is 1 byte addition, مش كده؟ 1 byte by 1 byte. I'm adding 1 byte to 1 byte. In DLD, when we add 2 numbers, assume they are unsigned. If I'm talking about unsigned numbers, what are the special cases that may happen while I'm adding the numbers? Okay, I may add those numbers and get a correct answer. Remember something, a microprocessor is giving me 1 byte to store the results. But we have, أيوة كده, we have a case called الناس الشاطرة هي كلها قالت an overflow. I may get an overflow. Adding 1 byte to 1 byte may exceed 1 byte. It will be 1 byte and 1 bit. Okay, so I want to indicate there is an error happen while I'm adding those numbers. Okay, this will go where? To the carry flag. يبقى الكاري flag is to indicate error. يبقى الكاري flag to indicate error in unsigned operation. لما الكاري فلاج ده يبقى بواحد يبقى معناها ايه؟ يبقى معناها ان last operation in add if I'm doing addition يبقى last operation ended up of an overflow for unsigned numbers. يبقى الكاري فلاج مخصص لمين؟ للunsigned numbers. طيب what kind of other errors I can have for the unsigned numbers? What if I'm doing sum? I'm subtracting AL with AH. I'm subtracting ايوه بالظبط كده I may get a negative sign مش كده ولا ايه؟ I'm subtracting unsigned from unsigned and I may get the result as negative. ليه؟ لأن السبتران is smaller than the is bigger than the median. يبقى الريزلتس هتبقى ايه؟ هتبقى negative. دي غلطة ولا مش غلطة؟ ده error. Okay? I want to indicate to the programmer, hey, that's why it's called flags. كأني برفع فلاج كده علم. خلي بالك. The operation that you just performed had some problem. يبقى الكاري flag will also be 1 if the result is negative. يبقى الكاري flag is to indicate error in unsigned operation. If I'm doing add, it will indicate overflow. If I'm doing subtract, it will indicate a negative result. يبقى الكاري flag 1 means there is an error in the last unsigned operation. For addition, overflow. For subtraction, negative result. بالظبط كده. يبقى الكاري فلاج هيبقى بواحد عشان يقول لي ان في مشكله. المشكله دي يا اما overflow يا اما results negative. Agree? Make sense? فهمنا الكاري فلاج؟ نخش على اللي بعده. اخر اللي بعده انا مش هتكلم على دول، هخش على اخر واحد خالص. الله، ده انا عندي هنا بيت اسمه overflow flag. اخر واحد خالص اللي هو نمره 11 اسمه overflow. This is ايوه كده، برافو يا احمد. ال overflow flag is for the signed twos complement numbers. والفلاج ده بيريز 1 لما يحصل ايه؟ when I have an overflow for signed numbers. يبقى if I'm doing operation with unsigned numbers, which flag to check? Carry flag. If I'm doing an operation for assigned twos complement numbers, which flag to check? The overflow flag. واضحة؟ clear؟ تمام؟ طيب. Next. The sign flag. What is the sign flag? A sign flag is simply, okay, the polarity of the most significant bit while I'm doing mathematical operation, irregardless whether I'm doing the operation for signed numbers or doing the operation for unsigned numbers. Okay, this flag will be raised, will match exactly the most significant bit, of the result. If a sign flag is the most significant bit of the result, no matter whether I am doing addition or subtraction for signed or for unsigned. Okay, so the sign flag is simply, okay, carries the most significant bit of the result. Okay, does this mean that this means the result is negative? No, it depends, because if I have an overflow, خلاص الساين the most significant bit of the result is not the indicator for the sign of the result. وعارفين الكلام ده من الدي ال دي. We will go over that with the examples إن شاء الله when we go to the program. Okay? But you have to go and review this from DLD. تمام؟ Any question? يبقى ال SF is actually the most significant bit of the result. أيا كان ال most significant bit ده شكله عامل إزاي. تمام؟ Agree? Make sense? نروح للي بعده. مين بقى؟ الزيرو فلاج. Okay? الزيرو flag indicates whether the result equals to 0 or not. Very simple. حد يقول لي ازاي اطلع الزيرو فلاج بالديجيتال لوجيك ديزاين جيتس؟ انا عندي عملت اوبريشن اهي ما بين 1 بايت و 1 بايت وطلعت 1 بايت ريزلت. Okay? How can I get the zero flag? The zero flag will be 1. The zero flag will be 1 if the result is 0. يبقى zero flag equals to 1. If the result is a non-zero, zero flag هيبقى بزيرو. الزيرو فلاج واحد لما الريزلت بصفار، لما الريزلت بصفر. الزيرو فلاج بزيرو لما الريزلت بواحد. واحد مظبوط. يبقى اذا اين؟ if I عملت اورنج لكل البيتس، لا اورنج نورنج مش عارف نورنج. انا عملت if I make an لا مش نور and نور يمكن نور صح. I want to detect that, so I want to indicate النور صح يبقى zero flag is knowing. لأن if I have any bit that equals to 1, I need this to be 0. If all of the bits are equals to zeros, the NOR will give me 1. يبقى مظبوط. يبقى هي NOR. Exactly. Perfect. يبقى this is NOR. If I make NORing to all the bits of the result, I will get the zero flag. صح. ما تزقوش حاضر. صح. NOR صح. النور صح. اوكي تمام. Agree? Make sense? Fine. What's next? We have two other flags that have special usages. اللي هم مين؟ الباريتي والauxiliary. الباريتي is also a useful flag. الباريتي بيعمل ايه؟ الباريتي is checking the results, the bits of the results. Okay? If the number of ones in the results is even, the parity will be the parity will be 1. بالظبط كده. طيب example عشان الناس تعرف. Assume that my result is here. Assume that I do some operation, I will get the result as 1 byte like this. This is my result. يبقى إذا الستيتس ريجستر ده نلاحظ حاجة إنه always updated by the results of the last mathematical operation. هيعمل إيه الباريتي؟ الباريتي is actually checking how many ones here in this result. This results have how many bits of 1? And 1, 2, 3, 4, and 5. I have 5 ones. ال 5 ones ده ال 5 ده even ولا odd؟ رقم 5 ده even ولا odd؟ رقم odd. Since it is an odd يبقى ال parity فلاج هيبقى بكام؟ بزيرو. اوكي؟ طيب what if my result was like this؟ I'm just laying out some bits here. Yeah. How many ones here? 1, 2, 3, 4, 5, 6. I have 6 ones in the result. تمام؟ يبقى هنا الباريتي ايه؟ الباريتي هنا based on this هيبقى بكام؟ الباريتي flag هيبقى 1. Okay? Why to use this? We will see some applications for this. تمام كده؟ Agree? The last flag is the auxiliary flag. What is the auxiliary flag? The auxiliary flag plays the same, it's actually the carry out for the first two nibbles of a byte operation. انت فاهم حاجه؟ محدش فاهم حاجه. هو بيت ملوش اي 30 لازمه من الاخر يعني وعمرنا ما بنستخدمه. انا مش عارف هم حاطينه ليه صراحه. The auxiliary flag is not that much useful. Okay, but since it's one of the bits, we have to mention it. What's the auxiliary? The auxiliary flag is actually while you are adding those bits together. Assume, let me just put an example here. Okay, I am adding those 2 bytes together, 1 byte and 1 byte. The first nibble of those, while I am doing addition, I am having the carry, مش كده؟ مش احنا بنجمع على دول بيقول لك ايه؟ 1 plus 1 is 0 and carry, مش كده؟ 1 plus 0 plus 1 is 0 carry. صح؟ 1 plus 1 plus 0 is 0 and carry. 1 plus 0 plus 0 is 1 0 carry. Can you see this last carry here? When I add the first 4 bits of the first number to the 4 bits of the first number. When I adding those together, I get a carry out of this. Let's go to the auxiliary carry. يستخدم في ايه؟ Not that much useful. Okay? It has some special case applications. We may go over one of them. تمام؟ عرفنا ال 6 flags for the status register. Yes, for sure. We will do applications. In chapter 4, we will do applications and we will use extensively almost all of the flags. Okay? Maybe the parity is seldomly used and also the auxiliary. But the carry flag, the zero flag, the sign flag, the overflow flags are heavily used. Definitely. Things will be more clear when we go to the examples. Okay? We're just explaining here the register. We are explaining the flags of the status register, and the applications will clarify all of this, inshallah, in chapter number 4. Not today. Right. Any questions? And this is the status register. Right now, we have finished chapter number 2. Okay? This is the end of chapter 2. Agree? So all what you have to know is to know the bits of the flags for the status register, and you know the usage of each of them. You have to discriminate between the carry flag and the overflow flag, know what's the sign flag and what's the zero flag. Okay, definitely also the parity and the auxiliary. Agree? Make sense? Any question? Clear? طيب. حلو. Now we want to move to chapter number 3. Addressing modes. And now I want to flip to the slides. لا. Ma have asked a question. Can you please explain what is aligned and what's misaligned word? And my answer to Ma, respectfully, no. Okay, alignment. We was always explaining it, and actually it's not that much related to the rest of the material for this course. So I decided to omit it. So you don't have to worry about the alignment. Okay, I'm not bringing any questions in the alignment. If you want to understand what's alignment and what we are using the alignment for, I can do this offline. Okay. Maybe if we have some free time during the lab, I will explain the alignment. It is not that easy subject. It is tough, it is complex, and it is not related to the functionality of the microprocessor. The alignment affects directly the performance of the microprocessor, so I actually decided to drop it. And we usually take not less than half an hour explaining it, okay? So it's not easy. Okay, so I just decided to omit it. So don't worry about any alignment question. I will never ask about alignment. Don't worry. Yes, it is not important for you right now. Maybe later on in the CSA, we may mention that because it's something related actually to the performance. So I decided to omit it from this course. Yeah. Right. Now, chapter 3. Today we are starting chapter 3, and I just wanted to put a kind of an introduction to this chapter. This chapter is actually explaining the syntax of start writing code in assembly. We need to know the taxonomy of the instruction. What are the different components the instruction is composed of? And actually what type of addressing modes that we have for each instruction. We need to discriminate between two things of the instruction, something called the mnemonic and something called the opcode. Okay, those are two kind of analogous things, but they have different meanings. What is mnemonic? The instruction actually is basically, any instruction is basically two more important parts. أي instruction خلقها ربنا في الدنيا في الأسمبلي are two parts. الopcode or the mnemonic. The mnemonic is what you are writing in assembly language, okay, in English. The mnemonic is 3 letters that represent the instruction. So for add, I will use ADD. For moving data, I will use MOV. بالظبط كده يا محمد. Okay. For subtract, I will use SUB. For multiply, I use a MUL. So this is what's called the mnemonic. The mnemonic are 3 or at maximum 4 letters that is descriptive enough to the assembly programmer to understand what instruction is written here for the it's a humanly readable format for the instruction. Okay? This is different from the opcode. Each instruction has an opcode. What's opcode? From its name, it is the operational or the operation code. It is in binary or in hexa, تمام? The representation of the instruction in the binary file. This is actually what the microprocessor reads and translates to know what kind of operation that you want to perform. تمام كده يا شباب؟ يبقى الopcode is the real number written inside the machine or inside your machine file or inside your binary file to represent each and every instruction in your code. So the mission of the assembler is to convert the mnemonic into opcode. This is the mission of mean of the assembler. يبقى شغلة الاسمبلر انه ياخد الانستراكشن ويحولها لارقام. تمام؟ طيب. Each instruction contains what? Contains two main parts. The opcode or the mnemonic and the operands, which are the variables the operation should be applied on them. In addition to those two essential parts of any instruction, we have also what's called the label and the comment. Okay? What is label and what's comment? We will discuss any of them. As a formal definition, a label is actually, again, a symbolic name that you as a programmer give to the address of the instruction. يا ريت نركز في كلامنا قوي. الانستراكشن ليها ادرس. ده ادرس فين؟ The instruction address is an address in where? In what? ما حدش يقول لي in memory عشان ايه؟ ما ازعلش منه. ما بنتكلمش عن memory، احنا بنتكلم على السوفت وير دلوقتي. خلاص بنتكلم على ال components of my program. The address of the instruction is ايوه كده. It's an address in the code segment. ومحدش يقول لي CS. لأن CS is the starting of the segment. يبقى الادرس هنا we are meaning offset inside the code segment. يبقى لما اقول الانستراكشن ادرس انا هنا اقصد offset inside the code segment اللي هو usually بيتحط فين؟ Which register is carries the offset of the instruction in the code segment or the microprocessor in the real بقى execution of the program. The address of the instruction is carried where? It is carried in ايوه كده برافو عليكم هند وزينب. Okay? The address of the instruction or the offset of the instruction, if I'm not talking about a physical address, I'm talking about a logical address or an offset address. It is usually at the execution of the program is carried in the IP, in the instruction pointer. While I'm writing my code, I can give label to this IP to allow me or facilitate to me or make it easy for me as a programmer, instead of dealing with the address as numbers, dealing with a name for that address. يعني ايه كل الكلام ده؟ We will see it in later on in examples. Okay. Last part of the instruction is what's called the comment, and this is optional. Both of those parts, by the way, is optional. A label is optional, وكمان the comment is optional. Okay. That means if you're writing the instruction, it could be a healthy instruction without a label and without a comment, but it should have mnemonic and set of operands. محمد بيقول I think مش عارف هي بيثينك في ايه مش فاهم ما فهمتش ده كومنت ولا سؤال ولا anyway. طيب وضح نفسك يا محمد شويه لان انا كده مش فاهم. طيب in slide here number 4 بالظبط السيمي colon. Okay, so we will talk about the syntax. Right now we are talking about the syntax. ميرا تقريبا عايزه تقول لي it is already 10:50 صح؟ مش كده؟ طيب يا ميرا خلاص اوكي يبقى we will stop here يا ميرا. احنا in slide number 4 and ان شاء الله on Tuesday before we start our quiz we will continue discussing the chapter for addressing mode chapter number 3 starting in slide number 4. خلاص we will stop here and I wish you the best of luck. Thanks a lot and have a good day today and see you inshallah on Tuesday. شكرا. See you soon. السلام عليكم.